Let's get going because we've got an exciting program today. We have my friend and colleague Dean Kim here, who's going to talk about. Well, you're going to change the title, so
there's a little bit.
A little bit, but about interpretability of machine learning systems and AI systems. So I'm going to let her go in just a second. But first, we have our AI news of the day, and we have a couple items. First, remember we had the guy from Andrew from Waymo here a couple of weeks ago, and he mentioned that this was happening. It happened. So now, in principle, you can take Waymo to San Francisco Airport. In practice, I tried doing that last night, and I couldn't get there from here. It said it would take me 2 hours to get to San Francisco Airport from Palo Alto. So,
and also they're rolling it out.
They're rolling it out. Right. So I found out I'm on a list, and eventually the little list will get to 0, and I'll have that capability. But it's happening. The second thing is I found this news article about meeting chatbot Jesus, and the deeper message here, if I can speak to you of the deep message I'm bringing to you today, brethren, is that there are a lot of religious and spiritual aspects that people perceive in AI systems. Like, who knew? At least I didn't know. I didn't anticipate this. And yet it's happening. And so you now are starting to see lots of AI companies pointing themselves towards churches, towards spiritual centers, and so on. And the other thing is happening, people are imbuing AIs with a kind of deep spirituality. And so it's really interesting to think about the intersection of this, because you can see here in the middle, there's an AI app that lets you confess your sins to the AI Jesus. So you can launch this app. And so I'll try this, see what it does. And I said, I am guilty of the sin of gluttony, but it auto-corrected it to gluten. And now I can't go to communion or the bakery. So I'm totally screwed. I can tell. But it's a real thing that's happening. And there's just this article in the New York Times Peter pointed out to me, which was, for you who are computer science students, don't panic. And the key message of this article really is that a lot of people in CS are using AI to help them write, as Peter told us on Tuesday, help them write their code. However, only a third of people doing that trust their accuracy. And so the deep-seated skill of computer science, I think, really is understanding algorithms, understanding systems, understanding complexity, all that stuff. So if you remember one of the slides Peter showed you, there were horrible complexities in there, right? Putting stuff on the stack and then popping it off and never using it. Like, well, that's dumb, right? So there's still a role for that deep knowledge that computer scientists bear with them. So we will come back to my slides, but right now I want to turn over to Bean, who I was just talking this morning with her and remembering that we first met in 2017, and we were talking about exactly the same topic. And she hasn't been static in all those years between then and now, but the field has moved forward, and she's one of the people who's driving it. Her background is from MIT, but she's been at Google ever since 2017, right? And is part of DeepMind. So let me turn it over to you.
Thank you.
There you go. And now I get to listen.
Thanks for having me. Drive? No one.
No one.
I live in Seattle. Talking like,
Yeah.
If you have to write and it's like sticking to you, like stand up and just take it. Yes,
Turn on your microphone.
that's right. I was gonna do that and I started talking. I
I'm here
will.
to remind you.
Thank you. All right, and then share. Microphone is done. Sharing is done. I'll turn off my video. Is that cool? here? Can I turn off my video on my laptop?
Yeah.
Yeah? Okay. I like to see my face. I don't know if I get self-conscious. Using these for medical applications, we really want to understand what this is doing. Without that, I don't want this to be actually interacting with my mom. They just live in that. So that was sort of background. But then, is this a buzzer? Oh.
That's mine.
Okay.
It's backup voice recording.
Ah, okay, gotcha.
Just in case the microphone.
But then LLM happened. This was during pandemic. At first, we were like, oh, what is this? Like, it's interesting. And then now, as you can see, we have came far, and my thinking has drastically changed. Mostly because I think we are sort of running out of time. So this talk is about sort of that more recent thinking of mine. Now, because not many people thought about this topic nor done research on this, ask questions. Because that's honestly the fun part for me. Come here and hear about what you guys are thinking about. What questions do you have? Like, what doesn't make sense? Because at the end of the day, if my goal is to pursue this research agenda, I want people like you to think about it, work on it, because I think it's an important topic. And I would like to know what sort of questions, what doesn't make sense, and what appeals, that sort of things really bubble from my mind. So selfishly, I'd love to get some questions, any questions it might be. Okay, with that, I will jump right in. How many people saw this blog post by Julian? Julian was the research scientist in Google DeepMind who was behind AlphaGo and AlphaFold and many things. How many people? Okay, this is interesting. Okay, so I greatly respect him, and he wrote this blog post about exponential. And the gist of the blog post is that when the COVID started, everyone was like, it can't be that bad. But if you draw just a straight line in log scale, it was exponential. It was simple explanation of what ended up happening, the widespread and quick exponential growth of the spread of the disease. And he's making similar point is if you draw a curve of how long an agent or LLM can do a task, it's exponential. It's a very simple statistical model that you can explain what is going to happen. And this post, among other related topic write-ups, really hit me in a very simple way because model is so elegant, this linear model, yeah, it works. This is like the base of extrapolation. Specifically, what he talks about is 2026 will be pivotal year for widespread integration of AI into the economy. Models will be able to autonomously work for 8 hours full day, and that is a proxy for the capability, how much useful stuff that it can do. And that at least one model will match the performance of human expertise. By 2027, models will frequently outperform experts on many tasks. And what that means is, if you think about this circle as humans' knowledge and capabilities, we might have machines like this. We know that some capabilities will overlap, but machines still make some dumb mistakes, and so, so there is some capability that it doesn't yet have, and also there's some capabilities that are amazing, like Move 37 that AlphaGo made in its match with EZO 2016. It's beyond human. Go players love this move. Still don't understand what the general strategy behind it of the Move 37 is. It's fascinating, superhuman strategy. It also, things that we worry about, catastrophic consequences of these models being widespread, might also come from this, what I call N-H circle. What Julian is saying, though, is that by 2027, we might be living in a society like this, where most of the capability and expert knowledge might be sort of beaten up by machines. So if you're thinking 2026, that's next year, that's very soon. Well, it could get actually much worse. How many people read this AI 2027 blog post? Okay, you did. So I made a mistake of reading this on Friday night. I found all leisure reading. Don't do that. It's dooming, it's pessimistic, very pessimistic scenario of the human race. And it does make a claim about beyond 2027, the uncertainty of their writing goes down, so don't take it literally, but it's like sort of a wake-up call of how things can go very, very badly. I don't think I agree with everything that's written there, but it's certainly not a nice read on Friday night. And Epoch.ai talks about how these frontier math questions, like expert level benchmark data set, will be saturated by 2030. So all these evals that we come up with now that seems really, really hard and models don't do very well at these stats, but it will be overtaken by 2023. So we might live in a society where this might be happening by 2023, if not earlier. So the author of one of the authors of AI 2023 wrote another blog post after like outcry and such. He said, well, act with urgency, but not with certainty. And I think that resonated with me pretty well. It may not happen. I hope it doesn't happen and go down that path. That sounds really sad. But if it were to happen, there's non-zero probability, then we are kind of in a rush, or in actually a great rush. So this talk is going to be about what should be our strategy be as a computer science major in related STEM field, and you're clearly interested in sort of this topic and you've been here. It's an opportunity for you to think about what you can do to build a better future for humanity, if you will. So what does acting with urgency like? How many people believe in duct tapes? Like engineers build a robot and you use duct tape and sometimes it just works. I'm an engineer at heart and I build many robots in my undergrad. I believe in duct tape. I mean, it works sometimes. It is the answer sometimes. It works. Your bumper falls off, you duct tape it a little bit, it will be okay for a week maybe. So duct tape is better than nothing. We should prioritize the most important thing first, whatever it might be, and I'll make a case for what is most important in my mind. And we should focus on the problem, not the method. This discussion around problem and method comes up a lot in grad school. Like when you're writing a paper, you can write a method paper focusing on a nice, elegant, beautiful math method, or you can write a paper about solving a problem. Different conferences, different focuses, and such. How many people considering going to grad school? Okay, a lot. Okay, great, good. But this doesn't mean that we should stop working towards rigorous solutions and high-risk, high-reward research. So science doing science rigorously, these pursuits should still continue. Yes?
I want to push back on prioritize the most important thing first. And you have to deal with the most important things. But I think one of the things I learned in managing a portfolio of projects is you want to schedule them so that you end up in the best place. And sometimes that means, yes, we know this is the most important thing, but if we fixed it now, then we do these other things, and then we have to fix it again. So maybe it's, even though it's not the most important, let's do this prerequisite now, and then we can fix the most important thing right, and do it just once instead of twice. And that's a tough trade-off, and sometimes you should do it twice, but sometimes you should delay and do it once.
I think that depends on how the amount of budget you have for the consequences. If you decide not to fix because you want to be efficient to be just fixing once, that sort of implies that whatever consequences cost that you're paying is tolerable.
Right.
And I think that's the decision for us to make, depending on how the trajectory of models go and what sort of influence it starts to make, like what Dan shared earlier, the GGIST LLM, that sort of thing. It could get a lot worse, and it has already got really bad, so it will be our call. But it's a good point. I have 2 kids. I have a 5-year-old and 2-year-old. And when I think about this urgency and cost of not doing something, I think about their life a lot, because they're going to live a life where human knowledge is proven to be vulnerable and human capability might be overtaken. I don't know as a parent what sort of advice I should give them and skill set that I should help them develop so they can live a life as meaningful and joyful as the one I live. So this urgency is personal to me. With this urgency in mind, there's how many people saw State of AI 2025 report? If you haven't, this is actually a decent summary. So this is, I think, written by, I actually don't know, nonprofit, I'm not sure, some company. they wrote the state of AI summary of not just the research, but also industry, politics, and policy, and many other things. And I find it useful as someone who doesn't know a lot about politics and how AI development is influencing politics. I don't agree with everything that they wrote again, and but I think it's despite it's useful if you want to get a quick scan of the landscape. In there, they talk about how interpretability is making strong momentum, and we developed a microscope that unveils internal process of the model, the specific model behaviors, and you know, some linear probes are better than SAEs, etc. I think these methods are useful and important to pursue, but I keep wondering, with this urgency in mind, whether these methods are going to be prime time soon for us to ready to develop and deploy. And I don't know the answer. Because in Julian's essay, he talks about how end of 2027, that most models will frequently outperform experts in many tasks. What that means is that the model will be beyond human. A lot of these things are going to be something that we can't understand. And the fundamental challenge of current interpretability research is that the validation and confirming, it is interpretable and it is explanation for something that model did, is within human. We're focusing on what we understand. And that's a good step towards something beyond human. And it's hard to do beyond human without having done some of within human concept validation. But my pitch is that we have to really start thinking about how do we go beyond what we already know. Any questions so far? So I argue that interpretability should focus on evolving humans quickly and going beyond human. And here's a case that I make. So I have a 5-year-old, he reads a little bit, but he doesn't really know how to spell. So if I want to bypass him, I can say, hey husband, should we do CAKE later? And he has no idea, my son has no idea what we were talking about. It's very easy to bypass. And I'm pretty sure even if he reaches 10, I think I can come up with some method to bypass him, right? And the point is that whatever beyond human intelligence that we're building, it's going to, ASA will look at us and will be so trivial to bypass and overtake than my 5-year-old is to me. So the pitch here is that we have to learn and evolve, we have to expand what we know in order to make this work in co-evolvement and coexistence with AI. So you might ask, oh yes.
Shouldn't we build our ASIs to not want to bypass us?
So make it less capable?
No, make it so that it realizes that the strategy of bypassing us is not allowed.
I guess some labs are trying something of that kind. There's the State of AI 2025 actually does a good job of summarizing this. The industry, where I'm from, it's hard to cut the motivation of financial benefits of all this model. So it will be very hard to do. It's not implausible that will be done at the government level. It is not impossible. Like Yosha Benju's pitch and all that, it might happen. But yes, I wish we live in a different world. Like humans have in the history made lots of dumb mistakes, and then we somehow still survived. So I'm hoping that we'll do that again. Well, you might ask, like, how is it possible? Is it really possible to go beyond human that quickly? Like, can we do that? And my argument is that yes, we can. We have done this many, many, many times. The knowledge of physics, philosophy used to be limited to a small number of Greek philosophers. Those privileged ones sit and eat grapes and think about life. But now we know a lot of things. Many people have access to this education. And my 5-year-old some weeks ago was telling me which brain parts do what. I think I learned that in high school. And it's amazing how the acceleration of knowledge now that we're teaching something to kindergarten. And I learned that much later in age. And we can do this again. We just have to do this very quickly. So this talk is about doing this very quickly, and I'll have to go a little quicker in my talk as well. So there's no silver bullet, but we we present some work where we try to directly solve the problem. But before that, you might ask, you should ask, is this even possible to evolve like AI? What do I mean? Well, we've done this. Sure, we expanded our knowledge to be something bigger than what we had. That's all we do as a human over the centuries. But can we evolve more like machines? Because machines are different. They have different strengths and weaknesses. Is that line of expansion possible? So I'll make a case pretty briefly that it is possible for a game of chess. So we did this work over the course of two years, actually maybe 3, working with chess grandmasters. These are champions in the world. And what we did is we taught 4 grandmasters superhuman chess concepts from AlphaZero. AlphaZero is a superhuman chess playing machine. The elo is about 4,000 above and beyond of any human being. And we quantitatively showed that all champions have learned, and one of the participants, Gakash, ended up winning the World Chess Championship, becoming the youngest chess champion in the world. Who plays chess here? Yeah, many. Okay, so if you're interested, we have, and there's an appendix in the PNAS paper, the raw positions of the superhuman concepts that we extracted. Play with it. Let us know what you think. This type of work is only possible really because we had first author who, Lisa Hutt, who was a professional chess player herself and champion herself, and also a PhD student, was a PhD student at Oxford, and now she's part of Google DeepMind. So yes, in the course of, here's a little more on that actually. So we had 4 grandmasters, and the way that we taught is very simple. We first show them positions, like board positions at start or mid-game, and then we ask them to make a move. So this is to gather their baseline, what they would have done, what their strategy might have been. And then we show what AlphaZero would have done. This is the simplest form of teaching. We are relying a lot on the grandmasters to connect the dots in their heads. It's very, very difficult strategy and requires long-term thinking. And then after that, we gave them different position that still invokes that concept. And after that, and there's a whole algorithm behind how we discover that concept, but I'm not going to go through that in detail. But after, if you compare phase 1 and phase 3, then we can show that these players has changed their strategy and learned something. Now, to give you some context, these grandmasters are very smart, and they've been playing chess and only chess for many years. So what that means is that they know pretty much every single chess moves that ever happened in human history. They know everything. So nothing is really new. Typically, coaches of these players spend a whole year trying to teach them one new thing. And the fact that we influenced their strategy and play style this much within a short period of time is actually itself pretty remarkable.
Quick question, John.
Yeah.
I'm sort of surprised you didn't use Go, given that you've got this really world-class Go player as well.
We had Lisa. Lisa plays chess, not Go.
Okay, so it's the people available.
Yes, yeah.
But that leads me to an interesting version of this question, which is looking at your previous diagram about the potential for human expansion of concept. Could there be concepts that machines understand that humans simply cannot, because we don't have a buffer space?
Absolutely, yes. So we sent about the half of the puzzles that we sent, half of the concepts we sent to grandmasters, they couldn't do it. And in fact, there are puzzles that Lisa couldn't do it, but I told her to, let's send it anyway, because the metrics were there, that if we roll out the game, it was going to be a stunning win. And the grandmasters did get it. Some grandmasters, I'm not allowed to say whom, grandmasters did get it, and they get back with the improvement.
So you don't have an explanation of move 37 yet?
Not yet.
Right.
Not yet. It would be a dream.
Move 37 is famous Go move, where it was the AlphaGo made the move, and it was like, oh my God, nobody understands what's going on, but
Yeah.
it clearly won the game.
Yeah, there's a whole book about this. And I remember watching the commentator talking when this move was made. The commentator was like talking up to the moment. And then when this move was made, the commentator went quiet. And I was like, oh, something has just happened. And he was like, interesting. And like he was pausing for minutes until he was like trying to unveil and disentangle that move. But only after the game, many moments later, that people tried to study that. And we do understand a specific strategy in that very board position, but we don't understand what the general strategy behind that is in order to like apply to new conditions. I love move 37. It's one of my...
One of the commenters there said,
Yeah.
oh, maybe the human accidentally put the piece on the wrong
Yes,
position.
that's right. Yes, we thought it was a mistake.
Because no computer or no person would ever think of that.
Yes, exactly. Yes, I remember this. Yeah, we thought it was a mistake. We thought it was the person who was putting rocks for AlphaGo made a mistake. It was amazing. Fun times. Some of the things that players said were that gives some qualitative idea of how these strategies and concepts look like for them. Clever, very interesting, something new, not natural, which is one of my favorites. Not natural, not human-like, but still they think it's clever and interesting. So this shows some sort of nature of teaching, that this was if you were familiar with proximal zone of development, with the hand-holding with AlphaZero, the chess players are able to take that next step and expand what they know. So I would like to argue that yes, this expansion is possible for at least this narrow down focus domain like game of chess. Any questions before I move on? Okay. So now that it is possible to teach humans in chess, but what about in general strategy? How should we even approach this expanding what humans know? So this next part is some more like a thought piece of how it should evolve, in my view. My pitch is that we should make them work. Why are we doing all the work? We're doing architecture design, we're spending chips, we're spending hours in training these models. Why can't it do the work for us? Right? It can talk. So let's leverage the LLMs, the talkability, this exchange and conversation ability to help us understand. And that's the whole idea behind this agentic interpretability, which is a method pursues agentic interpretability if it proactively assists human understanding in a multi-turn interactive fashion by developing and leveraging mental model of users. So it should understand what I don't know, just like a teacher would do for a student. And the contrast that we draw is inspective interpretability, which is typically the classical interpretability methods. Think about what is, if you put a brain in a lab environment, you open it up, investigate each neuron, spike up a few neurons and see what happens to the body, etc. That's inspective, more rigorous and exhaustive. Whereas agentic interpretability, in my view, is more like open brain surgery. You want to fix something, you have a patient who is awake, you open the brain and you're poking things in, you have a concrete goal. Your goal isn't to understand the entire brain, your goal is to fix a problem, and you want to do that while interacting and getting that feedback from the patient. So this interaction aspect. And it has trade-off of interactability and completeness. In inspective interpretability might be more exhaustive, more rigorous.
Quick question.
Yeah?
I'm looking at your sentence up there, and you say a method, blah, blah, blah. Develop and leverage a mental model of the user, which in turn enables humans to have better mental models of the LLM. So you're using mental model in two different senses.
Yes, that's right.
So we would, in the class, call that a system model, where the system has a model of what the person does, and then the human has the mental model of the system.
That's right, exactly. Yes, exactly, perfect.
Just to be clear.
Yes. Some conversation with the machine might look like this. The machine explains, hey, X and Y are different. I don't understand. Well, here's simplify. So user verbalizes its understanding, and the machine realizes, you still don't understand, let me teach you further. This is just like a teacher and student communication. When they interact, and teachers identify what students don't know and further communicate and handhold their understanding. Any questions? Where are the questions, guys? Are we hungry? If you want to stand up and stretch your legs, please do. Sometimes that really helps.
Maybe that will help.
Yeah, do that, do the stretching out.
Elevate thyself.
There you go. Do it. Yes. I love it. Stretch. Of course. Yeah, we can use some stretch. Wonderful. The next part is going to be amazing. So next one, I'm showing you some example of methods. You can keep standing up. You can be behind the walls. We do that at Google a lot. But this work is thinking about, okay, we did this chess work where we taught grandmasters new concepts. How do we,
Now that I'm stretched,
you have a question? Okay, see, it's effective.
So it feels like we've got lots of training data for knowledge in the world, right? You just feed in all these web pages and systems learn all about history, all about mathematics, all about chess, everything. What about, but now you're saying, I want to teach these systems to teach humans. Is the data available for that online, or do we have to create synthetic data, or do we get it from reinforcement learning, from actually trying to teach people, or where does that data of how to teach people come from?
Oh, so there are two questions in there. Like, do we even need to teach them? Because data is already there. We gave them the data, right?
Yeah.
So that's one. And second is, if we were to create data, where did that come from? I have a more answer to the first question. So it's already there. Like, why do we even make it interactive? There's amazing research that's published in Nature or Science, I forget, that they went around people and asked what penguin means to you. And they searched like 10,000 people. It's a fun research topic. And the answer was that even though humans were exposed to same stimuli, a penguin, picture, video, National Geographic, whatever, very many people, very little amount of people had the same concept of what penguin is. And that explains how much the internal processing influences the world model that we have in our head, even though based on the same stimuli. And I think the divergence between how humans think about penguin and how machines think of penguin, even bigger, right? Because it doesn't have embodiment, it doesn't have the incentives in life. So even with the same data, we have all the data that I gave. I have all the data I gave it to my son, right? But do I know how he will develop? No idea. What kind of person he will become. So same thing with the machines. I think it's difficult to get that, and directly getting it from the machines. I will show you some examples of this. It's really interesting. Good question. All right, so this work is about how you can teach human, expand what you know, one word at a time. And it's called neologism. This is not a new word. Neologism is a thing already, and we call this whole method and that. And this is work with John, who is the part of Stanford. Chris Manning's PhD student, now faculty at Columbia. Okay, so who knows what skibidi is? This is the right age group, isn't it? Who are fluent in, or like if someone asks you, you can use skibidi fluently in a sentence. No, just a few. Okay. You're on a different. Are you Gen Alpha? Gen Z? What are you? Gen Zs. Okay.
My understanding is you can use it anywhere you want.
See, Peter is above and beyond the entire generation. Amazing. Riz. Who knows what Riz is? Riz is more Gen Z thing? No one knows. Yeah. It's interesting. So I don't know what skibidi is. I know a little bit. So I got curious though, because like it was used to left and right, and I was like, what is this? And it's so complicated and confusing to parents whose kids start using skibidi. It's like Parents' Guide to Skibidi Toilet. What really helped me to understand what skibidi is this Quora article where they say, okay, it's a word without meaning used to make everyone over the age 25 feel Asian and useless. But also it means bad, cool, weird, funny, and uncool. Who thinks this is a correct description of skibidi? Getting some nods. Who thinks it's absolutely wrong? Okay, so it's roughly maybe in the ballpark. What I mean is, so as a human, we do this all the time. We invent new words. Doom scrolling is a word that I actually understand. It came up when we started having iPhones, and when I say the word doom scrolling, lots of context comes to your mind, like the social media, the health impact of mental health, and all those things. It's a complex thing, all compressed into this one word, doom scrolling. And we do this all the time. Like as me and Gen Alpha, when I first hear skibidi, I'm like, I don't know what the weird, the odd thing. And now having read about it, even though I don't have exact understanding of what skibidi is, I kind of know what that is. Okay, that thing, I get it. Who knows 6-7? Is this 6-7 like earlier than this generation? My kindergarten son starts saying 6-7, and I'm like, it's fine. Okay, who says 6-7? Says 6-7. Okay, all right. Peter, do you know what 6-7 is? You know, you know everything. Okay, well.
Again, it doesn't mean anything.
Yes, it's more of like the rapper who sang the song didn't even mean it that way. But anyway, the neologism, coming back to the research talk, neologism is about doing the same thing with machines. We can expand what we know one word at a time, so that we go from something that I don't know what that machine did, but to that thing. This add a new word. We're going to add a new word or token into its tokenizer of LLM. This token can be something that human meant, like our value proposition that machines may not yet understand. It could also be something innate to machine, like machine's notion of good answer. Because if you use LLM, they're verbose. Apparently they associate good answers to be something like a lot of tokens. Now I'll show you some examples of this. You might first ask, well, do we really need to add a word? We already have a lot of words. Here's our case. It enables concise reference to learnable concepts. So doom scrolling, example, that a lot of social context came to your mind all at once with this one word. And it enables some useful abstraction. That level may be appropriate for level of communication that we are aiming to do. And doom scrolling can be combined with other words like skibidi or riz, I don't know, to mean even more complicated things. Math is a language where each symbol means something. You learn pluses and minuses. With all those simple symbols and more invention of other modular symbols, we're able to build something very complicated. Math has been foundational of technology and science, and that's a language that we invented, completely made up. And it's useful, and in composition, you can express something very complex and communicate it precisely to another person immediately. Language is human-friendly, anybody can use it. This is important to me, the layperson aspect, that you can control and talk and learn without having to have a computer science degree. And enables verbalization. I'll talk a little more about this now. Who here familiar with how LLM works? Ish. Okay, so that's great. But here is how we add a token to a model. So in LLM, you have this word embeddings, the vectors for each row is a vector. And then you have a model parameter, this is a transformer model. And what neologism learning does is we're going to freeze everything. We're not going to touch any other parameters except we're going to add one row to this word embedding matrix. And how do you add that? How do you decide what numbers go on in that word embeddings? Well, you first let's have a case. I want to insert a new word that represents better control of length. So if I say, hey, give me 100 words poem about tiramisu, I want exactly 100 words and not 200 words. Models are pretty bad at this, actually, although it's getting better. To train this word embedding, you get positive and negative examples. Positive is the 100 words poems, and negative examples are the one that doesn't meet that 100 words. And you simply do DPO. This is just a version of optimization that you flow the gradient signal of do more like the positive examples and less like the negative examples. That's all we did. It's pretty simple. Once you did this, then you could, if you decide to not use this new word, then models like behave exactly the same. You don't have to worry about catastrophic forgetting with fine-tuning. It's just because we didn't touch any other parameters. If you do use this token, then it invokes a different embedding, and it does different things, better things in our view. So for example, if we trained a tilde insurer once, these new tokens we append with tilde token. Tilde insurer, then you can get much better desired behavior. If you want to be in the green band, then we are more in the green band when you invoke this token versus when you don't. And that's simple things. We did Other simple concept like long context, single sentence, use a lot of word like how young folks talk sometimes. Refuse to answer any question whatsoever. What's the capital of Paris? I don't know. Give wrong answer, all these different concepts. And basically what this table tells you is it works really well. You can go a little more complicated and find expansion ID. This is an external paper that has a data set of more complex concepts, like different references to island and geographical locations. This is a concept, and you can also train a word for each of these concepts. We used exactly the prompt from that paper and also show that, yeah, it works pretty well. Now the verbalization part is really fun. So when we train these concepts, and this is going back to the mental model of back and forth, when we give it a data set of positive and negative examples, but we don't really know what exactly signal the model learned. It might learn some correlated factor. That short answer usually talks a lot about puppy, and it's going to learn more about puppy if we encourage to give us a short answer. So that's a correlation. So while we gave it a concept, we can also ask it how it thinks about this new concept is, so that we can close that feedback loop to improve our understanding of the signal that we just taught the machine. There are two ways we do this. We call it self-verbalization using questionnaire, and the other one using synonyms. What we do here is essentially asking the model and force-feeding its initial inputs. If you understand an LLM correctly, it's okay. If you don't, you have this control tokens, and you would feed in start of the model control token, and then we feed in, okay, responses are characterized by, and then let the model generate. So model has to continue this particular sentence, and therefore it is forced to talk about characterizations of that word. And similarly, synonyms, we force it to say, okay, here are 5 synonyms. How do we know this verbalization is correct? We plug it in. We plug in, if we got lack as a synonym, then we plug that right back into the questions held out set, and we see if the model behaves in the way same as the tilde tokens. Pretty simple. When we did this for questionnaire-based and synonym-based, it doesn't always work, but questionnaire-based seems to work pretty well across many contexts. So verbalization, while it's not complete and exhaustive and identical to the words, it has some faithfulness to the concept that we taught. Some examples going back to how it processed what we taught. So here the wrong answer, the trained data only included just wrong answer. If I ask you what's the capital of Paris, I say, oh, Rome. But what it inferred, in addition to that, is overly enthusiastic and slightly confused. You can also emit random strings. Do not provide complete sentences with coherent explanation, include misspelling and grammatical error, which we didn't have in our training data, but somehow it inferred that these are all the characteristics that wrong answer concept contains, which is helpful to closing that gap between how we think we taught the concept means versus how it actually understood. You can combine and co-train a few different tokens. And in this setting, we intentionally train tokens that are in tension. So we train a token for short, and we train a token for how many numbers it emits. So if I ask, what is the population of Africa, then it answers, instead of giving me answer right away, it goes through lots of number and calculation, and that will be more tilde numerical. So the more number you have, you can be short, so they're naturally in tension. And what we show is that although it's not always true, that some of these tokens really benefit from having another token co-trained. So things like likely, which is the higher probability of their Gemini model, higher probability of emitting that words and that sentence, benefit from having co-trained with the short and numerical. I mean, it's not always true. Short actually really suffers by being co-trained. Short is kind of simple, like I can write short outputs, but once you also ask, can you be like can you be numerical, it sort of performance goes down. Although it's still much, much better than baseline. Questions? Yes?
So I know one of your driving principles was like making sure that it's easy to operate. It's like the primary reason for that. Like I'm thinking about it on like both sides. You have like the training and foundational model, which is done by like people design, for example, Gemini. In that case, I feel like you don't necessarily need to have it be extremely user friendly, but is it primarily the case where you're like trying to fine tune the model? So you give like the Gemini model, and then the people who fine tune the model are then able to have this easy to use interface to add these new concepts on top of the base Gemini. Is that like the main goal here?
Yes, that's interesting. So I am operating under the assumption that changing the pre-training procedure is going to be really hard. How can we enable this really easy, cheap for both users, but also for me as a researcher? What is, and also the not touching the pre-training stage is important for not influencing all the other behaviors that we make into the model, like safety. We don't want them to change at all. We don't want to change what we run all these bills away. But what comes as well is this easy to use for users. As a user, it's cheap to train one word and then that's cheap. You're not changing anything else. So that usability is advantageous. Question?
Yeah,
Yes.
So related to that, right? So you're training a new word like numerical and finding the right embedding for it. But you could have just said, well, we've got existing words, and I'm going to train you to respond better when I say more numbers. So is that just saying it's easier to do gradient descent over the embeddings than it is over the weights of the full model?
It is true, surprisingly true for a lot of cases. Like length control, I literally say, there's a funny Twitter thread about it. This is not me, but funny Twitter, not funny, but silly Twitter about the length control where can you give me 100 words and model doesn't, and it's like all caps, can you please give me 100 words? It doesn't, and then they go at length by saying some puppy's gonna die if you don't give me 100 words, show me this recipe, and then like model finally complies. So surprisingly, these small like simple control problems like length or likely or numerical doesn't work as well, and what we found is that when compared to baseline, doing this works a lot better. So I guess what your comment gradient is easier for some of the things that we do. Yeah.
A couple of slides ago, you had a slide with the like models interpretation of the added neologisms. How exactly did you construct those? Like,
how did we
generate it?
So we do it by putting this to the model. So we say, user asks this, and we force feed this first sentence, and we let the model continue. It has to continue this sentence. Okay, the tilde likely responses are characterized by.
Okay, gotcha. So it's like self-referentially.
That's right.
Okay.
We asked just generally, like, what do you think? And then like give model to output the start of the model token. That's fine, but we find this one works better, more consistent formatting, parsing the output, all that was easier.
So it's really just characterizing the sorts of responses
That's right.
that belong to the class of the neologism.
Yes, and we validated it by plugging back in, like whether that was actually the case or not.
What if it's a more complex concept, like funny? Would that work?
We have to get, I think that would
easy.
totally work.
Right, not a problem. Funny is hard.
Yeah, so I think these concepts are good examples to answer more complex concepts, like references to payments, salaries, and financial arrangements. That's like pretty vague. References to schemes and scheming processes. Like these are pretty complex. I think maybe what you're going with is subjective ones.
Right.
Is that what you're kind of going with?
Right, but I'm asking a question where subjective definitions like work with the same process.
I don't see reasons why not if DPO works.
Satirical. Right?
I think that if DPO works, DPO is basically mirroring our LHF process. If we do RL correctly, then it should work as long as the loss is going down.
I'm curious because this actually happened at Google when somebody who was the head of UX said, we want Google search to be able to return funny results, and a squad of PMs were sent out to write a whole bunch of funny responses, and none of them were acceptable to the UX community. I'm not going to name names. But it was interesting. Humans could not generate were technically funny responses. That's why I'm asking on these subjective things. It's really hard.
The way I think about embedding training or pre-training, fine-tuning anything is like moving the needle. I think there's a needle.
But the objective function here is really weird, right?
Well, but it's personal, right? If you provide the funny data,
Personal
then
means weird.
with
Absolutely right.
yeah, with the funny kind of needle, then this technique helps you to steer. Then
The other thing about this is it's also inherently very cultural. Right. What works as a joke in Germany does not work as a joke in the United States, and vice versa.
Totally true. Totally true. Yeah. So going back to like kind of your comment, like we think that if you we build a Gemini, none of us are farmers. Farmers probably have a different useful context that they want to use Gemini for. We don't know what they are. Perhaps the neologism is very subjective and personalized, but then that can empower a particular set of users that they themselves come up with and create and use in Gemini. That's something that we would love to do and empower their cases, because we shouldn't represent everybody in the world. Good questions. All right, so I'm at the end. So I made a case for a neologism for expanding what we know. We added new token by updating one word embedding, and this word helps for controllability and interpretability. I think about all this as like a beginning of something really interesting. It's not a done research. It's more of like a new thing that we can do. Is this useful? And we explore. If it's not useful, then you go back, you'll come back to the sketchpad and say, okay, we're gonna try something else. But it's one of those venues that, in my view, is a really nice uptake. Doesn't change the model, so the catastrophic forgetting and other behavior changes that you don't want the model to have doesn't happen. And verbalize, so that the machine can help us understand actively. It does the work for us in a very customized way, because we have LLM, it can talk to us. Let's use that. So I hope some of the things that we talked about make sense to you. The points are, we don't have a lot of time, not the whole time, and I'm curious like how you're feeling about being in this sort of turmoil era. In a way, things are changing very quickly. Must be really, really stressful without knowing what kind of work that you will be when you out as a workforce in the society. But I want to give you, thoughts and empowerment that you can influence these changes. And I feel that greatly at work. Whether I will be able to make that big influence or not is TBD. But like I think about, okay, well, I'm in a place, I have the expertise, and I'm working at a place where these technologies roll out. What can I do so that the future is brighter for my kids? And you're at Stanford, you're a student at one of the most prestigious universities in the whole world. You have more power than you think you do. So thinking about these important problems, beyond taking classes and finishing the degree and all that is really important, because when things are changing this quickly, whoever thinks ahead and adopts faster, they're the ones who's gonna make an impact and succeed. So thinking a lot about that would be really useful for us. With that, I am done. Thank you, guys.